This lesson is for FST, lesson 10.7 on mean, variance, and standard deviation of a binomial random variable. We talked about the mean of random variables back in lesson 10.4, so we're going to review that first. Each day for 4 days, a radio station is holding a raffle to give away a pair of tickets to an upcoming concert. In the past, the station has found that 80% of the raffle entries come from the local area. If this is the case, find the mean of the random variable x, where x is the number of winners from the local area. So you either win or you don't, so that's a binomial situation. So we're going to use and choose k, what's the rest, times the probability of success to the k times the complement of that, which is the probability of failure, to the n minus k. So we just have to find all the different parts here. So we've got 4 days, so that's 4 trials. And our number of successes is going to vary from 0 to 4. Probability of success is 80% that it's from the local area and 20% that it isn't. And so we're going to make a table that gives us all those different values, and then we can find the mean from the table. Let's do the table here. And so I used k here. I'm going to switch to x, but know that that value should actually be a k. So it's going to range from 0 to 4. And then I would go ahead and use the binomial PDF command on my calculator to generate all the different probabilities. You can either do binomial PDF with 4 trials and 80% chance of success. You can leave the next number blank and it'll give you all 5 outcomes listed horizontally, or you can type in which one you want it to do, and you'd have to do that command 4 times. So when you do that, you get these values. And let's review how you would actually now find the mean using this table. So a quick review that the mean of the random variable is the letter mu, and it's taking all the x's and multiplying them by their probabilities and then adding them up as you go. So let's write out that result, starting with 0 times 0.0016 and so on. So when you type all of that in, you end up getting about 3.2, I believe. Of course, depending upon what you would be told to round to. So that would be the mu, and that would be the mean of the random variable x, where x is the number of winners from the local area. So of the 4 days, 80% of that would be about 3.2 people who are from the local area. Let's also review the variance and standard deviation of a random variable. I don't have the formulas here. We'll just have to remind ourselves of what they are. Remember that the variance is very similar to this formula here. You simply square the x's as you multiply by the probability, and then you take away mu squared when you're all done. So the variance formula again is the sum of x squared times the probability of x. You take all of that and then you take away mu squared. So if we do that same thing on the numbers up above, we get 0 squared times 0.0016 plus 1 squared times 0.0256, and so on. So you do all of that, and when you're all done doing all of that, then you also take away the mu squared, and when you're done there, you should get about 0.64. And that would be the variance. The standard deviation would of course be the square root of that. So you'd take the number and square root it. But remember that today's topic is not about just the mean of a random variable, it's the mean of a binomial random variable. And I have good news for you. When the variable is binomial, you can calculate the mu much faster, but only in the binomial case is your mu going to be given with this formula. If it's a binomial random variable, then you can just do the number of trials times the probability. So let's take the same radio station question rather than doing all of this work that we did back here, finding all the probabilities by using the binomial PDF command and setting up the table and then having to calculate. Instead, we could have just taken the number of trials times the probability. And the reason for that again is because it's a binomial situation. So we would just do the number of trials times 0.8 and we would get the 3.2, which is what we got. Then there's also the same type of information for the standard deviation and the variance. So for the variance, you would just do NPQ. So that's sigma, lowercase sigma squared, that's the variance. And for the standard deviation, remember that's lowercase sigma, it's the O with the little hat on it. That one's going to be the square root of NPQ. So let's try that for our same radio question that we had done, radio station question. So we do N times P times Q to find the variance. The one that we did, N times P, was the mu. The variance here, we would just do N times P times Q. So we would do number of trials 4, probability of success 8, probability of failure 0.2. And when you do that, you get about 0.64. And then the standard deviation is just the square root of that again. So it would have been much faster to know that these formulas existed before, but now that we know that they do exist, anytime you know that the variable is binomial, you can just use N times P for mu and N times P times Q for the variance and the square root of that for the standard deviation. In class, we're going to do a bunch of practice problems for this just to make sure you've got it, so listen to your teacher for the instructions for future practice.